Okay, this webcast continues part 2 of the Projectile Motion Lab. So hopefully you have a table of data similar to this now, where you have changed the height of the cannon and measured the flight time. And so in our, so we're at step 5, I think. It says make a graph of the flight time of the projectile versus the height. So let's do that. Let's see here. So I've got my height and my flight time, and so I'm just going to highlight these numbers and let's insert a scatter plot. Oh, look at this. Okay, so let's first label this so we remember what it is. So this is the flight time of the projectile versus the height of the cannon. Okay, and so I have flight time in seconds, and I have height in meters. Okay, so this is a curved graph. And what function does this look like? It's not really a parabola. I mean, it might resemble a parabola that's turned over on its side. This is a square root function, okay? And so, so we're going to have to linearize this if we're going to create a physics equation for it. Let's see what it tells us to do. So it says what kind of relationship exists between the flight time and the height. Okay, so the graph of flight time versus height is curved and resembles a square root function. And a square root function would have a parent equation that looks like y equals some constant k times the square root of x. So that's the type of function that it looks like since our graph was curved in that way. Okay, so in order to linearize this flight time versus height data, we're going to need to take the square root of the height. The height was the variable on our x-axis. And so what we'll do is just copy that table. Let's just move it over here to the right of our graph. We're going to change this to be our linearized data. So it's no longer going to be height. It's going to be the square root of height. And so the units will not be meters. They're going to be meters raised to the power of 1/2, right? The square root of something is something raised to the power of 1/2. I'm just going to make my column a little wider. Okay. So I need to delete the original heights, because I don't want to get confused by them, but I'm leaving the flight times the same as they were. But instead of height, I want to put the square root of height. So I'm going to let Excel calculate this for me. And so I'm going to put a little formula here in this cell. You always start a formula with an equal sign, okay? And I want to take the square root. In Excel, SQRT is the way that you call the square root function. So I type square root, SQRT, I open a parentheses, and then I'm going to come over here to the first value of height, which was where my 1 is, 1 meter. I click in that cell. Notice that in my formula bar, it is putting the address of the cell that has the first height. And then I click in that formula bar and I close the parentheses. So I'm just basically telling it to take the square root of whatever number was in cell A3. Hit the enter key. Okay. So far it doesn't look too exciting, right? But it is correct. The square root of 1 is 1. I'm going to copy that formula down this entire column. To copy it, come back into the cell that has the formula, bring your cursor to the lower right-hand corner, and then just drag that down the length of the table. And it will, so like in the next one, it's saying take the square root of A4. And one below that, it says take the square root of whatever number is in A5. So it is going down the list of those heights and taking the square root of them. Okay? Once I've made this table, I want to graph it. And I want to see what does the flight time look like when it's graphed versus the square root of the height. I'm hoping it's going to be linear. But let me highlight those numbers and insert the scatter plot. Oh my goodness, it's beautifully linear. So this is what we were hoping for, because if we can make our data look linear, we can write a physics equation for it. So now this is flight time of the projectile versus the square root of the height of the cannon. Okay, let's see, we need some axis titles. So down here, my independent variable now is no longer height. Now it is the square root of height. And so that's in meters raised to the 1/2 power. And then my dependent variable is still flight time in seconds. Okay, so we have a very nice linear graph now, which is what we were trying to do. Okay. So the next step, it says use linear regression to find the slope of this graph of flight time versus the square root of height. So to do linear regression, I go to the Data tab, to Data Analysis, I choose Regression, and say OK. Now I have some existing stuff. I'm just going to delete it out of here. Okay. So now, when I put in the input of the y range, on my new linearized graph, the y-axis is showing flight time. So I highlight the flight time cells, go back to this form, and then I want to do the x range. On the x range, or on the x-axis now, it's showing the square root of the height. So be sure that you highlight these cells that have the square root of height. Make sure that residual plots and line fit plots are checked, and then say OK. Okay, here's our fitted line. I'm gonna go to Home, Format, and say Auto Fit the column width. And since it was a little scrunched up, it always is. And then let's look at this. It looks like a very nice fit. I can't see any of the original data peeking out from the fitted orange points. My residuals look nicely random. My R squared is very high. And so here is my slope, this 0.453. Okay, so I'm going to snip a copy of this. I'm going to put in my lab report. That didn't work. I'm going to snip a picture of this to put in the lab report. There we go. Now we put it right here after number D. And then, okay, it says, what is the slope? And so we had 0.453. Oh, we have to put units. I'm going to go back and look at the graph to decide about the units. So the units, must be in the wrong sheet. Sorry about that. Here we go. The units would be meters, or I'm sorry, seconds over meters to the 1/2. So this is a strange, but we could do it. This is a strange unit. It would be meters on top, and it would be the square root of meters below. I did that wrong. It's seconds on top. It's flight time in the numerator divided by square root of meters. There we go. So that is the slope. And we're just going to say the y-intercept is approximately 0. Okay, so that we don't have to worry about that. Okay, so a physics equation for this The independent variable now is the square root of height. And so I'm just going to call that square root of h. The dependent variable is the flight time, which I'm going to call delta t. And so I have delta t equals 0.453, and it would be, again, seconds over the square root of meter times the square root of height. That would be our physics equation here.